Hello, welcome to the sessions. Today we are going to solve some problem related to moment of inertia. This problem has been taken in English, the 17th and 18th problem. Okay, now let's just start with the first problem. Here it's a lamina, triangular lamina of mass m. What is lamina? Lamina is nothing, is like a plain sheet, right? Is the plain thing, that is a lamina. Here we have a triangular lamina of this two side L, and the hypotenuse is root L, obviously, because it's 90 degree. Okay, let's find out the moment of inertia of this shape, right? I will use very fundamental theorem, and will calculate the moment of inertia of this body. Okay, right, let's start. Okay, let me draw this again. Oh, forget, I will do here itself. Let's take this as a x-axis, sorry, this as a y-axis, and this as a x-axis. Okay, right, and at any distance from this point, this is a point O or B, whatever, this point O, at any distance y, take a small rod or small this is rectangle, right? This is a small rectangle from distance y, right? If this is very simple line, and equation of this line will be y is equal to x. Okay, then find out the area of this guy, area of this rectangle. Okay, area of this rectangle would be x, because at this point this is y, then x will be x into this distance will be x. 1 minute, let me put from some different color. This distance will be x. Okay, then the total area of this cylinder, let me draw this cylinder over here. This is sorry, no problem. Here we have one cylinder, right? And cylinder, this width of this cylinder will be dy, and this length will be x. Then total area of this is y dx is the area. Okay, for this equation y is equal to x, for this line y is equal to x, then dA means a small area, will be y dx, that will be equal to x dx. Okay, now find out the moment of inertia of this rectangle. The moment of inertia of any rectangle is ml square by 12. Okay, if you have any rectangle, like you have any rectangle, then moment of inertia along this axis will be ml square by 12, ml square by 12. Okay, and if you want to find out the moment of inertia along this axis, then you will use parallel theorem, ml square by 12 plus m, this L by 2 square, L by 2 square. Okay, L by 2 square. What you will get? You will get ml square by 12, ml square by 4, the total ml square by 3. The moment of inertia along this axis, moment of inertia along this axis of this rectangle, ml square by 3. Okay, and moment of inertia along the center is well known, ml square by 12, or along this axis. Okay, so now we need to find out the moment of inertia along this axis. Then I will use ml square by 3 formula. Okay, okay, the di is the moment of inertia of this infinitesimal rectangle. This infinitesimal rectangle will be ml square means mass dm, okay, mass dm into same formula ml, l is your x square by 3, okay. dm will be density into dA, okay. The dA means total m by total area, total area L square by 2, okay. This is your A into, this is your rho or sigma into dA, okay. This whole thing is dm into x square by 3, okay. Now take this one as it is 2m. What about dA? dA is x dx, okay. Now we have 2m 3l square, this is x square, and dA x dx x cube dx. Got it? Now you integrate it from 0 to L. Integrate it from 0 to L, 0 to L di. What you will get? This 2m by 3l square is common. You will get x power 4 by 4 means L power 4 by 4, okay. Then total I will be equal to ml square by 6, okay. This is very important formula, and you don't need to derive this whole bunch of thing. I will give you one intuitive formula over here. If you have any rectangular shape, let's take this, okay. If you know the height of this h, if you know the total mass of this m, mass of this rectangle, and whatever be the distance here, no problem, okay. Then moment of inertia of this kind of shape will always be 1 by 6 m into height square, no problem. If you know the height of this rectangle, of this triangle, height of this triangle, and then you can easily find the moment of inertia along this axis, okay. If you need to find out the moment of inertia along this axis, you need to find out the height from this axis, okay. The main formula which you need to remember is like for triangle, if you want to find the moment of inertia from any axis of a triangle, find out the height of the triangle from that axis, and then you apply this formula. This is height square m, total mass 1 by 6. That's it, okay. Now if you go for first formula, this is just a derivation, just to give you a glimpse how we got this formula ml square by 6, but in general we will always follow some intuitive formula. We are not going to derive every time, okay. We go to the first problem now. In this problem we need to find out the moment of inertia along this axis, okay. Then height of this triangle along this axis is L, okay. Well, and you have mass m, then moment of inertia. Simply moment of inertia in the first problem I guess 17, right? Yes, it is 17. Simply without doing any derivation, you can write simply I is equal to total mass by 6 into height square, and your height is here L, then m by L square by 6. Done, okay. Second problem is exactly same as what we have in the first one. You have two triangle now, okay. So you first find out moment of inertia of this, and then you add up this one. You got it, right? Here also you have again triangle. This triangle has a height something which we will calculate. This edge is A, then this will be whole bunch of thing will be A root 2, then OC will be equal to A root 2 by 2. means you got the height actually. In this case you got this height, this is your height. Okay, so you got height which is a by root 2. Good. Now you got the height, and then moment of inertia of this section along this axis will be I1 will be equal to m height square by height by root 2 square into 1 by 6. Okay, then this by 12, then you will get ma square by 12. Ma square by 12 here. For this also you will get ma. I2 will be equal to same thing, 12a square. You add this two up, you will get the moment of inertia. Just add it. Let me choose some different color here. You add it. I will be equal to I1 plus I2. Once you add it, you will get ma square by 12, and 12 means by 6. Okay, that's the answer. I have one more interesting problem somewhere here. Yes, here you have a total, you have this rectangular shape, and you need to find out the moment of inertia along this axis. Again you have this triangle. You find out the moment of inertia of this triangle you have along this axis. It means you need to find out the height. How to find the height? That is the problem here. That is the challenge. Okay, so we know the total B and L. B and L is the area, and the area we can calculate from here also, right? Area, because this is S into Q, S into B into L is the distance, right? SQ means SQ distance into height, you will get the area of this one, right? S into Q, S into Q by 2, actually S into Q into H by 2, you will get this area. If you doubled it, then you will get this. Okay, then this we can, using this formula we can get the H. H will be equal to B into L, B into L by SQ. Okay, so now you get your H. H will be B into L divided by B square plus L square root. Okay, you got H. Now you can get the moment of inertia along this axis. Along this axis you have height, then moment of inertia I1 because of the first section. Here for this section I1, for this section is I1, right? For other section I will calculate I2. I1 will be equal to m by 6 into H square. H square is our this one, right? B square L square divided by B square plus L square root into m by 6. Okay, the same thing will be I2 for this section, other half by this. For this section, let me choose some different color here. For this section you will get I2, same B square L square divided by B square plus L square. Yeah, there won't be any root here because here square B square L square into m by 6. You add these two up, you got your answer. I will be equal to m by 3, sorry, m by 3 B square into L square divided by B square plus L square. Okay, see you in the next lecture. Thank you.